Today I will show you how to prove Pythagorean's theorem using Bhaskara's proof of dissection. First, you start off with the right triangle. The triangle's sides will be labeled A and B, and the hypotenuse will be labeled C. Next, we add 3 triangles around it to create a square with the area of C squared. The only problem is it also has a square on the inside, so we must subtract that from C squared to figure out what the area of that is, and then add the areas of the triangles. Since the square on the inside sides are a minus b, so c squared is made up of parentheses a minus b, parentheses squared, and something else. Our next step is to rearrange the triangles to create 2 rectangles with the area of AB. Since there's 2 of them, AB plus AB is equal to 2AB. So c squared is equal to 2AB plus parentheses a minus b, parentheses squared. Then we instead of parentheses a minus b, since it's squared, it will be parentheses a minus b, parentheses a minus b, parentheses. Then using FOIL, first, outside, inside, last, we can figure out how to simplify that. So first would be a times a, or which would equal a squared. Outside would be a times negative b, or negative ab. Inside would be negative b times a, or negative ab2. Also, and last would be negative b times negative b, or b squared. So parentheses a minus b, parentheses squared, is equivalent to a squared minus ab plus b squared. Because negative ab minus ab is equal to negative 2ab, we can simplify even more so that parentheses a minus b, parentheses squared, is equal to negative 2ab plus a squared plus b squared. Putting that back into our original equation would be c squared is equal to 2ab minus 2ab plus a squared plus b squared. Because 2ab minus 2ab is equal to 0, we can cross those 2 out, so it ends up being c squared is equal to a squared plus b squared, which is Pythagorean's theorem. Thanks for watching, and I hope to see you again. Bye.